Here we go, another improper integral. So this one ranges from minus infinity to infinity. And one of the things that we have to do when we do one that goes all the way from minus infinity to infinity is we have to break it up into two separate integrals. So I'm going to break this up into the integral from minus infinity to 0 is going to be my midpoint, and then I'm going to go from 0 to infinity. So here we go. It just popped up for you there. So I go from minus infinity to 0 of the same thing, and then from 0 to infinity of this guy here. Now, in order to go about doing this, I need to integrate that. So do a little scratch work down here. I know that the integral of 6 over 9 plus x squared fits an arctan, or a tan inverse scheme or whatever, right? So I get, if I were to have this with a 3 here, it would be tan inverse of x over 3. I'm not going to write my plus c because I'm doing definite integrals. So the question is, what number do I need here to make it so that I multiply out and I get my actually, I think there's a better way to do this. Instead of looking at that 6 like that, I'm going to rewrite it as a 2 out front, and then I'm going to replace the 6 with that 3. So you should see now that, hopefully, that I want to put a 2 here to make this balance. And this over here is still equivalent to what I got up top. So there's my first part. I basically took this guy and did it up here, and I am evaluating it as a goes to infinity. Sorry, as this goes to infinity, and this should be a 0. So now I got to do the other half of it, because that piece corresponds with this guy. So now I got to get what this piece corresponds with. So what that is it's the same integral, so I don't have to do any work for that. It's just now plus the integral from 0, undo, redo, plus the limit as a new variable, new dummy variable, b, approaches infinity, of the same thing to tan inverse of x over 3, evaluated, and now I'm going from 0 to this b value. So you should know that tan inverse's graph looks like this. It's got an asymptote, this is pi over 2, this is negative pi over 2. So arctan looks like this. It's kind of a crude version of it, but it gets closer to those asymptotes. So what that's going to help me do is, you should see that this height is pi over 2. And if this is tan inverse, then as I evaluate this, as I try to plug in infinity for this, so as I plug in bigger and bigger numbers for x, this thing here is going to go to pi over 2. So maybe I'll write that out. So I get plus, getting pi over 2, undo, 2, that's this guy, times pi over 2 minus, now you should see that the tan of 0 is 0, so I can just plug that in and get 0. And then for this one, I get, first thing I'm going to do is do this thing here evaluated at 0, so I wind up doing tan of 0. So that once again gives me 2 times 0 minus, and now as I let this go to this a value, which is negative infinity, that's like sliding out this way. See, I go to a negative pi over 2, so I get minus a negative pi over 2. Now, to simplify this, I just get double negative, that's a plus, so I get 2 pi over 2, and then the next term here gives me another 2 pi over 2, which is the same as pi plus pi, which is going to break down to 2 pi as the answer for my definite integral. And it would not, I couldn't have done this if I had tried to, or it wouldn't have been the correct way to do it if I hadn't broken it up into this 2 separate integrals, this guy and this guy.